Hi, my name is Jay Lee, and I'm the Nextflow ambassador for Korea. And today I'm going to show you how to migrate the Nextflow workflow to the AWS HealthOmics service. This presentation was originally presented at the Nextflow meetup for Korean users in Seoul, and I'm re-recording this with a video to share the information with a global audience. Just a quick note, I'm recording this in October 2025, so please keep in mind that some features may be different later, and depending on when you're watching this video. This means I'm not going to tell you about the detail about the AWS, like for example, how to create an EC2 instance or an S3 bucket. So if you're not familiar with AWS services, it may be a little difficult to understand this video. And if you're fine with this, then let's begin. So here's a quick overview. First, I'm going to talk about what AWS HealthOmics is, and next, I'm going to show you how to migrate a Nextflow workflow using the NF Core Sarek workflow as an example. And then I'm going to show you how to run the workflow. And finally, you will see how to check the results, logs, and so on. And so, what is the AWS HealthOmics? AWS HealthOmics is a serverless service, which means the underlying infrastructure is fully managed by AWS. You don't need to worry about provisioning, maintaining, or scaling infrastructure to successfully use HealthOmics. And that means you pay only for the resources you use, and since resources are released automatically when the work is done. And also, HealthOmics has a very cloud-native design and is well integrated with other AWS services like S3 and CloudWatch. And today we are going to talk about only Nextflow, but it also supports other workflows too, like WDL or CWL. And finally, you can run workflows on huge scales with HealthOmics. So let's go through what kind of services are included in HealthOmics. There are four main components: private workflows, ready-to-run workflows, storage, and analytics. Some regions may not support specific services. As you can see from the table, the Seoul region doesn't have all of these services yet, but this could change in the future. Um, and now let's see what each one does. So first, private workflows is for running your own custom workflows, whether it's your own script or one from a community like NF Core. And next is ready to run workflows. This is a collection of workflows which AWS has already built and optimized. We'll be skipping them for now. And next is storage. It's a special and cost-effective storage solution designed for the files we use in bioinformatics. And finally, analytics. This transforms and loads your data into stores where you can query using Amazon Athena. And all right, now let's talk about the setup we need. To interact with HealthOmics, we need to run commands using the AWS CLI. This will allow you to control AWS services through commands in a shell. To do that, we need to set up an environment to use this AWS CLI. There are three main options. First is AWS Cloud Shell, which you can launch directly from the AWS console. And since you're running commands inside the AWS environment, you don't need any additional setup. However, it can be inconvenient for file management. Second option is to use a small EC2 instance. This provides a more persistent environment. However, it will incur a small cost and you'll need to configure some security settings like an IAM role. And the last option is to configure the AWS CLI on your local machine. This can be the most complex to set up as it requires you to manage AWS credentials securely on your own computer. I'll assume that you choose the right environment that fit to yourself. And now let's go into the next page to see how to actually use commands to set up the environment. First, we are going to define two variables, region and account ID. The region variable specifies the AWS data center region we will be interacting with. It is important to understand that this isn't your physical location, but the location of the AWS services that you are connecting to. This choice matters because service availability and pricing can differ significantly between regions. And for today's demo, I'll be using the US East one, and the account ID variable is your unique 12-digit AWS account ID. You can find this number in the top right corner of the AWS management console if you connect to the console page. Next, we will use the AWS CDK. This AWS CDK lets you automate building your AWS environment with code instead of manually clicking in the console. The CDK bootstrap command helps prepare the initial resources that the CDK needs for deployment. And now we're going to clone the AWS HealthOmics tutorial Git to the environment. So you may have a question like, why do we need to clone the HealthOmics tutorial Git repository? The short answer is we need a specific script for the repository to solve a compatibility problem. Let me explain the background. Most NF core workflows, including Sarek, use Docker container. The container images are often built for multiple CPU architectures, and the information about which architectures for the image is stored in a multi-architecture manifest. And here's the problem. HealthOmics doesn't fully support multi-architecture manifests. It requires a manifest for a single architecture. So the workflow provides a multiple architecture manifest, but HealthOmics cannot use it directly. To solve this, we use generate a single architecture manifest, and which is compatible with Amazon ECR. The ECR is AWS's fully managed container registry. By generating the single architecture manifest, the Sarek workflow's container images is optimized to the HealthOmics. It's important to note that this conversion step may not be necessary in the future. AWS is actively working on native support for multi-architecture manifests, which would eliminate this workaround entirely. As a reminder, this video is being recorded in October 2025, so I highly recommend checking the HealthOmics documentation and workshop to verify the current requirements. So let's see how to actually prepare the manifest file for ECR. First, we are going to clone another Git from AWS. I'll put this Amazon ECR helper for AWS HealthOmics directory in the home directory. After that, we enter the directory and run the command npm install, and then use the command cdk deploy to install the tool. Next, we are going to clone the workflow project we want, and this time it's Sarek. And then we copy one JSON file from the helper directory to the home directory and name it namespace.config. And now we're ready to convert the manifest file from Sarek using a Python file from the HealthOmics tutorial Git directory. You can change the output name in the following command. Two outputs will be generated from the written command. First one is a sarek dev docker image manifest.json, so JSON file, and omics.config, so config file. It's just name, but don't forget to declare the region also later. Two outputs will be generated from the written command. First, a sarek dev docker images manifest.json, and second is omics.config. And don't forget to declare the region at later. Now let's see the generated files. First, the JSON file is written as follows. There's a chance that the path in this file is not compatible. You don't need to modify it right now, but only if your migration fails, maybe you should check it. Another generated file is omics.config. You can see the file is like a Nextflow file. I will show you more details from my local VS Code. So when you see here, you can see like there's a parameters, manifest, conda, docker, and some process is written like this. See the the container path also like that. Yeah, it's like a Nextflow file. Alright, after we successfully generate the manifest file, we need to pull the public container and push it to our private ECR registry. To do that, we're going to use step functions from AWS. The OMX ECR Helper app helps prepare the containers. Simply, if your account has the proper IAM role and security setup, then this code will work okay. So yeah, just run it. And after you run the command, the application is a few minutes to run. Please go to the AWS console and check that the status of the step function turns into succeeded. We also generate the omics.config file. This file needs to be moved into the Sarek directory. So we're actually modifying the Sarek project that we cloned from GitHub. After moving this file, add a single line into the bottom of the nextflow.config file to include our new configuration. Now it's time to compress the modifier Sarek workflow. First, let's declare the name of the bucket. I pre-made a bucket with the name my tasks a bucket 5277 and numbers, and exported this name as a variable. Next, since the Sarek we were working on is compatible with ECR, I'm going to name the zip file sarek underbar ecr.zip. And then we're going to copy the zip file to the S3 bucket with the AWS S3 cp command. And finally, this is the real migration part. We're going to use the AWS HealthOmics create-workflow command to create the workflow in the HealthOmics service. I declare the workflow name here for convenience and run the AWS command that follows. One thing you need to know is that I skipped the parameter template options for the command. This option asks you to define the parameters of the workflow in advance. But the thing is, if you skip this option, the HealthOmics service will automatically detect the parameters from the workflow zip file and add them to the workflow definition. That's quite convenient. And if your workflow is uploaded to HealthOmics successfully, you will see output like this below. Each workflow gets its own ID. This means if you create the workflow with the same Sarek zip file for 2 times, there will be 2 workflows in HealthOmics service with different workflow ID. If you use the AWS Omics list-workflow command, you can see the workflow ID like this. All right, you have watched how to migrate a workflow to HealthOmics. Now we get another question in our head. Is it really useful, or how does it perform on AWS? If we were using the command line instead of HealthOmics, then we could simply use the task profile from Nextflow. But unfortunately, HealthOmics does not support that feature currently. So I was wondering, like, how can we prove that using HealthOmics is better or faster with data? In the end, I recreated the task profile in the AWS environment to fairly compare the performance between my local computer and AWS HealthOmics service. This is also helpful for you since I'm going to show you how to run the workflow in HealthOmics. So first, here is the list of the files that the task profile uses in the Sarek workflow. If you want to try the same process, please download these files and upload to your S3 bucket. One thing I'm going to point out is the sample sheet file. On this presentation page, you can see the sample sheet file with the name fastq underbar single.csv at the bottom. When you run Sarek, you need to provide a sample sheet file. And if you're setting up a cloud native environment, I assume you have already uploaded your FastQ files to an S3 bucket. And in that sample sheet, you need to write the path to those files. The path must start with S3. This input.json file is the list of parameters that Sarek needs. if you're following my process to recreate the task profile, you need to make a JSON file like this, and don't forget to change the answer passed to your bucket. And I should point out one more thing, that it's the outdir parameter. You can see that outdir parameter is written as /mnt/workflow/popdir/. And in short, if you run this workflow, the output files will be located in the path structure like this. And first your bucket, and then the output directory you will define, and then the workflow, and finally the popdir directory. I will show you later, but just remember that you shouldn't forget the MNT and workflow in the past. And some other options might be incorrect in this video, but they were just working well when I tested them in this month. All right, here I'm declaring variables again for the next steps, and some variables are declared twice, but please just ignore that. I just wanted to make sure that, since sometimes you might shut down the session. Next, we're going to define two JSON files, a role and a policy for the role. Simply, you just need to copy and paste the code, and I will provide this code later in my GitHub or through other materials, so please check them later. And this is the policy part. All right, we've actually set up everything, and we prepared the files in the S3 bucket with the JSON file and the role and the policy also. So we also set the name for the run right now. Feel free to make it as you like. I've named mine as like a Sarek_official_ test. And you also need to specify the role and the parameters file in the comment. And now one more big important part is the --output-URI parameter. As you remember, our input JSON file has a parameter called outdir with the value /mnt/workflow/popdir. And here's how they work together. So the path you provide in as the path you are going to provide in the output URI is mapped to the /mnt/ directory inside the workflows container. And HealthOmics then automatically adds a directory for the unique workflow ID. So in the end, the final output path will be structured like S3, and then your bucket, and in here workflow -output, and then your workflow ID, and after that popdir. After you run the comment, you can check the run on the AWS HealthOmics page. Click the runs button in the left menu, and then you can see the runs you have made. As you can see here, I have made 19 runs here, which includes some failures. And when you click the run ID from this page, then you can see the screen like this. The name of the run will be placed at the top of the page, and you can see the status, ARN, or runtime, and so on. And this run on this page is not finished yet. And if you realize that you ran with the run parameter, then you can quickly click the stop run button to stop the process. Once the run is completed, you can see the status has changed to completed on this page. And all right, and here is the review of the results. Once again, I ran the task profile from my local computer and recreated the environment in AWS with the HealthOmics service. For computing specs, AWS HealthOmics was definitely better, but if you it supports from 1 to 24 CPU cores and 1 to 30 gigabytes of RAM. But actually, the runtime was almost 10 times longer on the HealthOmics. As you can see on here, my process took only like 5 minutes 39 seconds, but the HealthOmics took 49 minutes. So before explaining the reason, let me tell you a bit about how HealthOmics manages computer resources first. Basically, if you specify computer resources for each task in the workflow, AWS will choose an instance type to satisfy that requirement. But if your workflow doesn't define the specs, then AWS will choose the smallest computing resources to do the task. These are the resource requirements of the task from Sarek. Still, before explaining why AWS HealthOmics took more time than my local computer, let me explain you one more thing clear. Was the task profile recreated properly in HealthOmics? And my answer is yes. I think I recreated the environment quite perfectly. So here's the comparison of the result from my local machine and the cloud. The multi-QC file, which is the final output of the process, was generated with the same contents. A little tip for you is that you can use Amazon QCLI to quickly access files in S3. I simply ask the QCLI first to compare the results. And now let's talk about the runtime. When you go to the AWS console, then navigate the HealthOmics and click on the run ID you're interested, then you can see a run task tab. When you click the Run Task tab, then you can see details about each task of the workflow. From this page, you can see how much time each task took, its CPU and memory and GPU usage, and when it started and finished. You can see that each task didn't take that long, but actually, since I ran the task profile, the input was quite small, so each task took less than a minute. Then why did the whole process take 49 minutes to finish? And here's the reason. It takes a few minutes to initialize each task and import files to the instance. This preparation took from 1 to 4 minutes per task. And here you can see for tasks like alignment and marking duplicates, the preparation pace took there 3 to 4 minutes, and while the actual processing took less than 40 seconds. And here is same. So what's the reason for the wait time? HealthOmics needs time to prepare for each task. When I ran the same workflow at different times, the total runtime was sometimes shorter than 49 minutes. That implies that the wait time can vary. This is an inevitable part of using a serverless service like HealthOmics, but if you run the workflow with large input file, the big advantage is that you can access to a high performance computing environment without having to buy and set up the physical hardware yourself. To tell you more about the HealthOmics webpage, you can also check the workflows parameters here. Remember that we let the HealthOmics service automatically set up the parameters from the workflow zip file. When you go to the private workflows menu, you can see the workflow list, and when you click on the workflow, you can see a parameters tab. Also in the run history tab, there is a list of runs that use this workflow. You can also click the run ID from here. And when you click the run ID, you can see the details of the run again. Now I'm going to talk about how to check the output files. There is a View Run Output button on this page. When you click it, it will lead you to the S3 bucket. Do you remember when I was explaining the output directory path? The path inside the container was /empty/workflow/popdir. The view run output button from the previous page leads you to the S3 URL that you defined with the --output-URI parameter. And in here, you can see two directories, logs and popdir. The logs folder has just a single file called engine.log, and it contains basic log about the run. It's not the same as the Nextflow log file, but I'm going to skip here. And the popdir is where the final results are saved. This corresponds to the path you defined in the outdir parameter in the JSON file. One of the most well-known AWS services for checking logs is CloudWatch. CloudWatch is AWS's monitoring and observing service. When you click View Run Manifest Logs button on the run page, it will lead you to CloudWatch and show you the log events for the run. And here you can see detailed information about each task, such as its status, a timestamp, and log message. Also, you can check the AWS Billing and Cost Management service to see how much you are charged. And if you want to estimate the cost beforehand, you can also use the AWS pricing calculator. All right, this is the end of my presentation. Thank you for watching this video, and I really hope it helps you to use HealthOmics with Nextflow.